Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to describe a little bit about what a Taylor series is and go through some calculations of how it's calculated. So first of all, let's talk about what it is. A Taylor series is a polynomial approximation of a function, and this is how it's calculated. A Taylor series as a function of x is equal to, if I have a function f of a, and again you calculate a Taylor series at a point. So a would be the x value that we're calculating the Taylor series at. So the Taylor series would equal f of a plus f prime of a times x minus a plus f double prime at a over 2 factorial times x minus a squared, etc. The thing to do is study and kind of notice it's a pattern here. This is a constant term, a linear term, a quadratic term, a cubic term, and so forth, and you can go as high and high as you want. Now I'll talk in other videos about error and convergence and things like that. The purpose of this video is just how to calculate a Taylor series. So we're going to go ahead and calculate a Taylor series for y equals sine x at x equals 0. So the Taylor series for sine x is going to be f of 0, sine of 0 is 0, plus f prime of sine is cosine of 0 times x minus 0, plus f double prime, now that's going to be the derivative of cosine, which is minus sine of 0 over 2 factorial times x minus 0 squared, plus, I'm going to go ahead and do one more term here. So this was y, this was f prime, f double prime. The next term is going to be f triple prime. Now the derivative of minus sine is minus cosine, evaluated at 0 over 3 factorial, and then I usually just put etc. This basically goes on forever and ever and ever. So cleaning this up a little bit, this is going to be a 0, cosine of 0 is 1, so the first term basically is just x. Sine of 0 is 0, so this entire term is gone. Cosine of 0 is 1, so we're going to have minus 1/3 times x minus 0 cubed, plus, and then it just keeps going forever. So our Taylor series expansion for sine x looks like x minus x to the third over 3 plus etc. And you need one or two more terms. I think that other term is going to be x to the fifth over 5 and so forth. But again, the purpose of this video is just to go ahead and get an idea of how Taylor series are calculated. I'm going to go ahead and do cosine function next. So if you just hold on here, I'm going to clear this. Okay, I'm back. Made myself a little room here. Now you'll notice, when you're doing Taylor series, you need a bunch of derivatives. I'm going to go ahead and do those first here this time. So if f is cosine x, f prime is minus sine x, f double prime is going to be minus cosine x, coming from derivative sine is cosine, but there's a minus sign in front of it. F triple prime is going to be the derivative of this thing, which is going to be positive sine x. Let me get a couple more here. F to the fourth is going to be the derivative of sine, which is cosine. And then f to the fifth is going to be the derivative of cosine, which is minus sine, and so forth. So our Taylor series expansion, or our Taylor series approximation for cosine x, and again we're going to do this around x equals 0, is going to be f of 0, which is going to be 1, plus f prime of 0 times x. Now that's going to be, I'm looking here, minus sine of 0 times x, so that thing is just 0. The next term is going to be plus f double prime of 0 over 2 factorial, so double prime here is minus cosine, evaluated at 0, it's going to be a minus 1, so that next term is going to be minus 1 over 2 factorial is just 2, times x squared, plus, f triple prime. Now the sine of 0 is 0. I'm just going to put a 0 here to shorten this up so I have some more room. Plus f fourth derivative term. Cosine of 0 is 1. And then we're going to have over 4 factorial times x minus 0 to the fourth plus, and I usually just put dot dot, etc. So our Taylor series expansion here for cosine x is 1, and this term is gone, minus x squared over 2. This term is gone, plus x to the fourth over 4 factorial, which is 4 times 3 is 12 times 2 is 24. Plus, and then I usually just put etc. So there's our Taylor series expansion, and the idea is basically this. The more terms you keep, the more accurate your approximation is. If I just, look at this just graphically here, just for a minute. Remember when you graph the cosine function, what it looks like. So here's just a quick little sketch here. The cosine function does this. Remember, cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is minus 1, and so forth. Now we're doing this expansion around x equals 0. So basically, this is kind of the region here where our expansion is good. And you'll notice that if I just lop these x's off, if I only keep one term, this is our Taylor series expansion reads basically just 1, but you'll notice that's actually a reasonable approximation if x is really small. Now, if we want to kind of vary out a little bit, this minus x squared term starts taking this, which is Taylor equals 1, and turns it into a quadratic that opens down. So what it does is it gives us a little bit better approximation there. We can go a little further out with less error, so to speak. And then when we add this term, what happens is our Taylor series just gets better and better around this area. And by better and better, it just becomes a much closer approximation further out. So that's kind of the idea. The more terms you keep, the further out we can go from x equals 0. So anyway, I hope this video helps demonstrate how to calculate a Taylor series. I think I'll go ahead and make a few more. Have a great day.